Question 4a. Salicylic acid is a naturally occurring carboxylic acid widely used in organic synthesis. There's the structure. The flowchart below shows some reactions of salicylic acid. In the box below, draw the structure of the organic compound formed by reaction 1. All right, so we've got a synthesis, well, a portion of a synthesis route here. I'll move the paper up a little bit to see a bit more. Okay, so again, so when you're dealing with this, look at the functional groups you've got, think about how they behave, think about the reactions you've learned about these functional groups. So what have I got? I've got a phenol molecule group here, and I've got a carboxylic acid group as well. Okay, so I'm reacting this molecule with excess sodium hydroxide. What's going to form? Well, I know here carboxylic acid, and clues in the title, sodium hydroxide's a base. Acid plus base makes a salt and water. Okay, so I'm looking for only the organic compound, so I can ignore the water here. What I want to draw is the organic compound. So let's start off with that. I'm not going to change the benzene ring structure, but what I am going to do is replace the hydrogen ion with a metal ion. Okay, because this is an acid, that's a base. Acid and base makes a salt and water, and that's all you're doing here. You're showing the acidic reaction by replacing the hydrogen ion with the metal ion. Now, what might be advisable in any situation like this is to put charges on those different ions there, because the COO becomes a minus, becomes a negatively charged ion, and the sodium is a positively charged ion. You don't have to have them. There's no indication that says you have to put the charges on there, but it just clarifies a few things. Now, secondly, I've got the OH group here, but because that OH group is essentially a phenol, phenol is weakly acidic, and weak acids will react with a strong base. Well, phenol will react with a strong base. It won't react with a weak base. It won't react with sodium carbonate, but phenol reacts with a strong base. So the same thing happens on the hydrogen of the OH group as well. So that's going to become ONA. Now, that is commonly one that's missed off. It's forgotten about. Remember, phenol is a weak acid. It behaves like any other weak acid. Alcohols don't normally do that. Okay, so if there was another carbon here and this was then a primary alcohol, that wouldn't happen. Primary alcohols aren't acidic enough for that to happen, but phenol is. So watch out. If you've got a benzene ring with an OH group directly attached, that is a phenol group and will behave and react just like you expect phenol to. So both of the hydrogens will be replaced by sodium ions there. Be careful. Part 2. Describe what will be observed during reaction 2. So let's see what's happening. So again, we're dealing with the reactions of phenol. So the phenol molecule reacts with bromine. It's a direct reaction. You don't need any other conditions. The phenol is more reactive than benzene, so this reaction can happen. And using bromine is a way of testing for the presence of a phenol. Specific observations happen. So phenol and bromine should normally produce a tri-substituted molecule, but because we've got the carboxyl group on there, you don't get all three substitutions taking place. We have got one happening, but the same observation will happen. So there's two things. As the bromine reacts, the bromine will decolorize. Okay, just like bromine does when you react with an alkene, it's the same principle. The bromine is reacting, it's no longer there anymore, so the bromine orange color, the bromine will decolorize to become colorless. The second thing that happens when bromine reacts with any phenol compound is a white precipitate forms. Okay, specify the color. So 1 mark for this one. In this case, I think the examiners would accept either or, but I would err on the side of caution and put them both down. Sometimes it's more than 1 point for 1 mark, and both of these are perfectly acceptable observations for what happens when bromine reacts with phenol. They both will happen. The bromine decolorizes and the white precipitate forms, or the white solid forms. Don't just say it changes color or turns white. You've got to refer to the fact it's a solid. So white precipitate forms. Part 3. Write a chemical reaction to represent reaction 2. Now, this is fairly straightforward. You've got the main constituents of this reaction already there. You've got the reactants there. You've got the salicylic acid and the bromine. You've got one of the products. It's just working out how the bromine is fitted onto there and balancing it all out. Okay? Whenever you're dealing with equations using benzene compounds, that's why you've got this space here. You've got blank space. You won't be given lines because you can draw the structures. You haven't got to try and convert it to molecular formula. That muddies the water. Keep it in the form you can see it. So I've got my salicylic acid. OH, COOH. reacting with bromine, producing this brominated compound here. Again, keep the groups as you can see them on the right carbons. If you move things around, you risk losing marks. Now think about what's happening. Any reactions of benzene are substitution reactions. So originally here there was a hydrogen. That has now been replaced by one bromine. I've got one bromine left over. It's Br2, there's only one there. The byproduct then is HBr. Okay, just like when benzene reacts with bromine, it's the same thing. HBr forms because the substitution, the hydrogen has been removed there. Picture the mechanism in your mind.